Well, hello and welcome to this video. We're going to be looking at graphing of exponentials on there. And so I'm going to actually do this with Desmos so that you can see what's going on. Now with Desmos, I put into this a table. And so what we're going to be graphing is 2 to the x. Okay, so an exponential equation. And if you remember, the basic formula for an exponential is y equals ab to the x. So in this case, our b value is just 2. So we're going to be looking at what the graph of an exponential looks like. So I'm going to just start with 0, and so it will automatically graph here. So as you see this, when I put in 0, 2 to the 0 is just 1. And then 1, 2 to the 1 is 2. So we'll go ahead and put in some points. There's 2 squared, which is 4. 2 to the 3rd, which is 8. 2 to the 4th, which is 16. And so we're going to start running off of our graph. But you can see this is what is called an exponential growth, because it is going up, and it's going up very rapidly. Now I'm going to back up because I just started with 0, and I'm going to put in a -1 and show you what happens there. So if you look at a -1 now, it's actually 1/2. -2 is 1/4. -3 is 0.125. -4 is 0.0625. It almost looks like it's on the 0, but if in fact I bring the graph larger and larger of a scale, you can see it's really not touching the x-axis, although it looks like it. So I'm going to go ahead and put in a -5 and see it is on there at 0.03125. And I can just keep doing that and putting in smaller and smaller numbers. And what you're going to see here is this is going to get, and again, it's still not touching on there. And so what happens is we call this line here really an asymptote, which means that my equation there is going to get closer and closer to the x-axis, but in fact it's never going to touch. I mean, even if I put in something like a -100, look at that number, it is still really small. But if I come over here, let me just show you, if I come all the way over here to a -100 and then I make this larger and larger, if I can get it that far, I don't even know if I can, and show you that it technically doesn't touch. But again, I am just expanding it and expanding it, and it does look like it touches, but it's not, because I'm over here only to -1 times 10 to the -5. So I would have to just increase this and increase this and increase this on there. So again, let's bring this back in. There's my -100. It looks like it crosses, but in terms of my t-table, I can see that it doesn't, because it's not a negative value. In fact, it is a very small negative, okay? Or a negative exponent, so a very small fraction. And that is what an exponential growth looks like. Now, we've done this before, and so I'm just going to go ahead and pull that one out here. Well, we'll just leave it in there. I'm going to go back to my equation, and just to show you, well, I'm going to leave that there. So I'm just going to come on down here, and I'm going to put in y equals 3 to the x. Okay, and I want you to see now the difference in the two. So 2 to the x, which does go up very quickly, but look how much faster 3 to the x goes up. And so again, I can put in y equals 4 to the x. And you're going to, whoops, what did I just do there? Oh, I did 4x, not 4 to the x. Let's back that up just a hair there. And 4 to the x. I knew something was wrong there. And so as you see, by increasing the base, 2, 3, 4, it's actually taking my graph and making it steeper and steeper and steeper on that. Very similar to your quadratic, remember, because the bigger it got, the steeper it got. Now, that's if I'm using numbers, again, that are 1 or 2, 3, 4, so forth. So that's an exponential growth. Now, I do want to show you what happens because it's really kind of interesting. I'm just going to pull these out real quick. Actually, I'm going to pull out the whole thing. And what happens if I put in a negative value? So y equals, and we're going to put in a -2, okay, to the x power. Now, I want you to think about this before I put it in, because I'm talking about a -2 to the first power, a -2 squared, -2 to the third, -2 to the fourth. I want you to think about the value that you get every time. What is a -2 to the first? What is a -2 squared? What is a -2 cubed? And then let's look at the graph and see if that makes sense to you. So we're going to put in an X there, and I want the graph of it. And what do we see? I'll even hit a return. I don't see a graph. Do you? On there? Okay. Well, here's the reason why this doesn't work, guys, is because if I take and put in, and I'll even do it a different way, I'm going to put it in as a table, and let's just see if we get anything different to look. So we'll do a table, and again, I'm going to come in here, and I'm going to do, -2 to the x, okay? And look there. It even tells me, it says, try another variation. Too many variables. Try defining x on there. Well, let's see. I need to put in a 1. That'll work. Let's see. Back that up. Whoops. So remember, we always have to tell it which one. So there we go. So now let's just look at what happens. So we've got a 1. Okay, that works. -1, -2. Okay, we finally got us a point. I got it to work. Let's put in a 2. Well, 2's up there. Well, okay, got another point. Let's do 3. 3 is down there. 4 is back up there. Do you see what's happening? It's jumping back and forth from a negative to a positive. Guys, this is why in our definition of a exponential, it specifically states that that b value must be greater than 1. Okay? Because what this is going to do, it's going to keep jumping back and forth. It's not going to make a pattern. You cannot have a b value that is a negative. Okay? Just remember that, because you're going to get this weird looking graph. Okay? So we looked at when b was positive. We looked at when b was negative, which we know that can't happen. Now let's look at what happens when I change that, and I'm going to do 1/2. Okay? I'm going to do 1/2 to the x power. Okay? 1/2 to the x. Again, I need to put in 1 so that it knows that. Okay? Now we've got, and I've just got the, let's just put some numbers in. I'm going to back up and get 0 in. And let's get a -1. And let's get a -2. And a -3. Okay? So this is called, guys, an exponential decay, because it's going down. And again, it's the same thing is going to happen as it gets closer and closer to that x axis. That's going to become the asymptote. It's not actually going to cross that x-axis. And again, I could put it in as an equation so you could actually see the line. We'll go ahead and do just the 1/2 so that it goes on top of the other one to the x. There it is. Okay? And again, you see it looks like it's touching, but in fact, if I spread this out, if I keep going bigger and bigger and bigger and bigger, and we'll see how if I can get it, because Desmos doesn't work the greatest with this, but it actually will not touch. I should elongate this. I don't even know if I can get it to do it, to show you. But anyway, it does not touch. It is, again, the asymptote line, and I got that fairly small. But what you could do, if you wanted to get this back to a scale that I can look at, to show you again, what did I do with my scale? Got it all messed up. Let's go back out. Here we go. There we go. What I could do again is put in, let's say, 50, and see how it's 8.88 times 10 to the negative 16. That doesn't mean it's a negative value. It means it is a very small value. Okay? So there is an example again, exponential decay. Exponential decays are when your b value is a fraction. So I'm going to take that one out, leave that in. Let's just again look at the difference, and let's get me another equation in here. So let's compare that to what happens if I do, let's do a 1/4. Okay, let's do a 1/4. Oops, hit the wrong button. To the x. Oops, not times x. I need it to the power of x. Okay, so now we're looking at the blue. Okay, so 1/2. 1/4 is smaller. Okay, and let's go bigger. So let's go y equals, what would be, what do I want to do? Let's go 1/10. We'll just put in 1/10 so you can see the difference there. So I'm getting smaller and smaller with my b value. Okay, and now we're looking at, let's change the, whoops. Well, don't want to close it. I want to change the color of it. Yeah. Anyway, it's that inside green one. I forget how to change the color right off. Okay, and so by taking that value, and then I can close that out so you can see which one it is. Okay, so it was steeper. So 1/2, 1/4, 1/10, it does make it go steeper, sharper, if you want to call it on that. Okay, so that's the difference between an exponential growth and an exponential decay. So I'm going to start another one just real quick just to show you a couple more things about it, but that'll be enough on this one for now.